Hello, friends. Welcome to Science Talk. I am your host, Jim Massa. I want to discuss with you what you see here. Now, it's an article that appeared about 15 months ago. And in the interim time, things have gotten worse. And so what we're looking at here, cascading consequences of the loss of Arctic sea ice. All right, so let's go through the article. Losing the remaining Arctic sea ice and its ability to reflect incoming solar energy back to space would be equivalent to adding 1 trillion, with a T, tons of CO2 to the atmosphere on top of the already 2.4 trillion tons emitted since the industrial age began. And this is based on research from current and former researchers from Scripps Institution of Oceanography at the UCal San Diego. So, first of all, let me play this short little video here. And let's see if I can just kind of move myself down there for a bit. And see if I get the volume up.
Spiritual. Physical. Impact. Global scale content. Which is called albedo.
And it's IDC out of Boulder, Colorado.
The coldest regions of the planet. She's found that altering the reflectivity of snow and ice has global system.
So Ryan, as you can see right here, the snow is very, very bright, which means it's reflecting most of the sun's energy back out into space. Here's a term called albedo, which basically defines how the sun's energy is coming in versus how much is being reflected back out by the surface. Let me show you something that's pretty important.
Okay, just in case if the audio faded there for a moment. Basically, albedo, most of you I'm sure know by now, is how much sun energy is reflected back into space. In other words, not absorbed by the planet. And Professor Stover does a nice little demonstration, as you'll see momentarily.
Check this out, right? This is a really good example of the difference between albedo between rock and snow. Because if the rock is a low albedo, it's been absorbing a lot of the sun's energy, heating up and melting that snow.
So the rock is heating up.
Okay, if you the preview, let me see if I can pull that up here. What this is showing is we see these folks represents light rays, I guess, but the sun's over here. So I guess so the energy is coming in this way. So what's happening here is this is showing being reflected back into space, where it hits open water, like here, here, and here. It's absorbed by the water absorbs the sun energy. Where it hits the ice, it's reflected back into space. So that's what these lines are trying to illustrate.
Well, basically, it's large parts of our planet. Not the back of snow and ice, and exposing darker surfaces such as rock or the ground.
Would you expect to be able to go to these polar regions with lots of ice and see this ice will back out?
Well, we are seeing
You see, again, sun energy reflecting off the ice back into space, and now it's being absorbed by the water.
I apologize for the poor audio. Apparently, the computer did not pick up what was being said, even though I was hearing it quite loudly. So, my apologies on that.
So, what's interesting there, what is the take home from that? Obviously, other than the point, ice reflects sun energy back in space, but it reflects up to 80% of the energy. That is a lot of energy to reflect back into space. You don't have the ice there anymore, that energy is now being absorbed by the surface, be it the rock or the water. That is a major contributing factor as to why the Arctic is warming as fast as it is, to now in some locations 3 times faster than the planetary average. Very, very serious. And it's only gotten worse in the 15 months or so since this article was originally published. Now, I wanted to discuss with you what we see right here. Algae, in this paragraph, algae that live in and under the sea ice play a much greater role for the Arctic food web than previously assumed. In a new study, biologists at the Alfred Wegener Institute Helmholtz Center for Polar and Marine Research showed that not only animals that live directly under the ice thrive on carbon produced by what we call ice algae, even species that mostly live at greater depth depend to a large extent on carbon from these algae, basically whatever sinks down through the water column. This also means that the decline of the Arctic sea ice may have far-reaching consequences for the entire food web of the Arctic Ocean. Their results have been published online in the Journal of Limnology and Oceanography. We now know that ice algae play a much more important role for the pelagic food web than previously assumed. Well, I've known about this for over 20 years. This finding also means, however, that the decline of the ice could have a more profound impact on the Arctic marine animals, including fish, seals, polar bears. Now, I did a video recently called Ice Algae, and I discuss all about ice algae. The point I wanted to make in that, and that also tied into my overturn mixing stratification video, that when you have Arctic sea ice, as that ice melts back, as with the onset of spring in the summer in the Arctic, you have that melting water that creates a little stratification, and then you have what's called ice edge productivity. That ice edge productivity helps supply, the basis for a food web there. As summer proceeds and the more that ice melts back, and the angle of the sun gets higher in the sky, we then switch over to the more pelagic phytoplankton that can do their thing and create another bit of a food web. As we lose the Arctic ice, there is less of the ice edge productivity that will take place. The pelagic productivity will not just simply start just because there's no ice, we can start photosynthesizing. The angle of the sun is not high enough so that the sun energy can activate the electron transport chain system found within the chloroplast, the chlorophyll, which is the pigmentation inside the phytoplankton, to start the whole photosynthetic process. So that's an issue. Losing the ice edge productivity results in an overall reduction in productivity in the Arctic Ocean. That's the message. So now this article goes on to discuss what's happening with whales. There's a lot of increased mortality of whales. Well, whales, especially the large baleen whales for the most part, go to high latitudes, that'd be Arctic Ocean, North Pacific, Southern Ocean, to feed because of the rich productivity there, lots of krill, other organisms that they need. And then they migrate to equatorial waters to have their calves. If the ice edge productivity is declining and overall productivity is declining, then that means there's not going to be secondary or tertiary productivity. There's not going to be enough food for the whales. That could be a reason why they're washing up dead. They're starving to death. That's my hypothesis. And we now know that the oceans are tending to stratify, which is further bad news for productivity in the oceans. So we're already starting to see reduction in productivity starting to impact organisms, be it whales, seals, fish, polar bears, walruses, etc. Even zooplankton. If you lose, if there are organisms that say habitate under the on the underside of the ice, and that ice is gone, their home is gone. Their mortalities are going to increase. So to say that the food web is in danger of collapsing, no, it is. We're seeing signs that is the collapse of the food web is already underway. This is very alarming. So I want to go to here. The pace of global warming has been grossly underestimated as the world keeps increasing its carbon emissions, rising in 2018 to a record 33.1 billion, would it be, tons CO2 per year. The atmospheric greenhouse gas level has now exceeded 560 parts per million CO2 equivalent. That is, 560 is not just simply only CO2 being measured, but includes methane, N2O as well into the calculations. This level surpasses the stability threshold of the Greenland and Antarctic ice sheets. Translation: melting is going to happen very quickly. In other words, those ice sheets are going to become unstable, and the rate of melting will increase even more so than what we're seeing. And they're already increasing exponentially, so we know that means they're going to increase ever more exponentially, the melting rate. The term climate change is thus no longer appropriate. I agree. Should be climate crisis. Since what is happening in the atmosphere-ocean system, accelerating over the last 70 years or so, is an abrupt calamity on the geological dimension, threatening nature and civilization. Ignoring what the science says, the powers that be are presiding over the sixth mass extinction of species, including humanity. I have said many, many times, as scientists, we do our studies, we get our data, we do the analysis, we see what the data indicates, we make our recommendations, we recommend what we would consider to be appropriate policies to implement, but it's up to the politicians, the policymakers, to heed our recommendations. And so far, that's not the situation. Definitely not here in the US. I'm seeing some slight encouraging reports coming in from the UK trying to go zero emissions by 2050, etc. But the time scales are too long. And also, really, when you think about it, getting to zero emissions is not as simple as it sounds. So everyone drives an electric vehicle. You still got to plug them in. And what powers the electricity to your home? private power plant that burns coal or gas, or diesel, right? Not zero emission. What's the biggest user of plastics? Medical industry. Those IV bags, the tubing, to the needle that goes in your arm. Well, except for the needle, everything else is plastic. Plastic is an oil product. So getting to, while I applaud the desire to get to that, it's not as easy as it sounds. Climate change is now reaching the end game, where very soon humanity must choose between taking unprecedented action or accepting that it has been left too late and bear the consequences. He mentions black carbon particles from Siberian forest fires. Well, those particles settle down on the ice and snow. It's black, starts absorbing sun energy, increasing the melting of the snow. In other words, the albedo is reduced because instead of the snow reflecting the sun energy back into space, the black soot absorbs that energy. And that further increases the melting rate. Mentioned Zach Labe. Zach does wonderful work. You can follow him on Twitter. He's always posting what's going on with the Arctic sea ice. And here it says, marine food web isn't going to collapse, it's collapsing now. And the final comment it makes is that the impending ice-free Arctic Sea is that we don't need to have crossed the official definition of an ice-free Arctic to see the 50 gigaton methane discharge from the clathrates and hydrates as hypothesized by Dr. Natalia Shakova. Now, Natalia is someone I know. Her husband, Igor Smelatov. They're two excellent scientists, and I worked with them. They have been tackling the methane issue for, probably over a quarter of a century now. In 2010, Natalia published what I consider to be a seminal paper on the methane issue. She looks at what's going on in the ESAS, the East Siberian Arctic Sea, looking at the shelf. She's been, she also looks at the Laptev Sea and so on, but she's looking at the methane releases from the shelf all along the Arctic Ocean. And she's basically saying that there is a methane time bomb ready to go off. She and Igor have been trying to quantify how much methane is in the clathrates, the hydrates, and the permafrost, and so on. And they're trying to get a handle on the rate of release. And they're very concerned, and they rightly should be. But Natalia has done stellar work, as has Igor, and they're really two really nice people. So I want to flip over quickly to this article, which repeats a lot of what I mentioned at the outset here. And then it's from scripts.ucsd.edu//news/research. Research highlight loss of Arctic reflective sea ice will advance global warming by 25 years. And it was an article that appeared, I think it was in June 2019, published June 20th in the journal Geophysical Research Letters. The title is Radiative Heating of an Ice-Free Arctic Ocean. So what I want to highlight from this page here is that losing the remaining Arctic sea ice and its ability to reflect incoming solar energy back to space would be equivalent to adding 1 trillion, with a T, tons of CO2 to the atmosphere on top of the already 2.4 trillion tons emitted since the industrial age. At current rates, this roughly equates to 25 years of global CO2 emissions, thus speeding up the arrival of a global threshold of warming of 2°C beyond temperatures the world experienced before the Industrial Revolution. Now, what this is saying is, by removing the Arctic ice, and therefore now we have that sun energy being absorbed and warming up the Arctic region, that warming would equate to, if you didn't lose the Arctic ice, you would not see that level of warming for 25 years based on current burning of fossil fuel. In other words, Arctic ice does not disappear. It would take 25 years to reach the level of adding this extra 1 trillion tons. But because of losing the Arctic ice, that extra amount of carbon is now added very quickly. It won't take 25 years. That's basically what they're saying there. So this will cause the planet to possibly run the risk of catastrophic damage ranging from more intense heat waves, coastal flooding, stronger, nastier storms, a mass extinction, threats to food supply if that threshold is passed. Well, I did a recent video called Lessons from the Early Eocene, where basically researchers were modeling this. And it also ties into the BOE, which I'll explain in a moment. And what they found in this research was that with the accelerated warming and ice melt, and the exponentiation of all of those, along with the putting CO2 in the atmosphere, thawing out the permafrost, adding more methane, more N2O into the atmosphere, that by 2100, when this research, you can check out my video on this, the planet will warm up by 7 to 9 C above pre-industrial revolution levels. A lot of other studies saying 3 to 4. That's now being shown to be an extreme underestimation. So why the difference from 7 to 9, maybe 10 C by 2100? Because what's difficult to model is water vapor or clouds. It's a double-edged sword. If you have cloud cover, the cloud traps any heat that radiates off the surface. But the top of the clouds reflects sun energy back. So it's extremely difficult to model, and water vapor is a greenhouse gas. Let's be clear about that. Because, and studies have shown that CO2 working in conjunction with water vapor has a higher warming effect than CO2 alone, water vapor alone. I mean, when you burn gasoline, you're burning an alkane. The products of such a combustion is not just CO2, but it's also water vapor. Don't believe me? Look at a tailpipe when you see something dripping off the end of it. That's water. So what about the BOE? BOE stands for Blue Ocean Event. Current models suggest that between years 2022 to 2024, somewhere in that realm, we will see an Arctic Ocean that has absolutely no ice at all for like 2 months in the summertime, like August, September, when September is basically the oceanic summer. BOE plus 2 now states that there will be 4 months of no Arctic ice. Now, in the past, oceanographers have basically defined ice-free as being, less than 1 million square kilometers of sea ice. And that was usually typically from 85 degrees north to the pole, in that little area. Well, now it's like, no, there's no ice anywhere. You can sail up to the North Pole without use of an icebreaker. So BOE plus 2 is 4 months. BOE plus 5 is 8 months of the year. BOE plus 10 is the Arctic Ocean is ice-free year-round. And it keeps absorbing energy that even during the cold, dark months, it doesn't lose enough energy for ice to form. And then it retains that heat. Then the next summer, you put more heat in the system, and you basically start rapidly warming up the Arctic Ocean. It's another feedback loop, positive feedback loop. So this is a major concern. Well, the authors of the study conclude that the loss of sea ice will add a globally average 0.7 watts per square meter of solar heating to the Earth's system, the entire planet. 0.21 watts per square meter have already occurred between 1979 and 2016. So in other words, you look at this, okay, so in, let me do some math here, about the 37 years or so, 0.21 watts per square meter have been added to, of solar heating has been added to the Earth's surface. Let's now basically more than triple that amount in the coming years. This shows you how, how important that albedo is. No ice, no albedo, and now we start tripling the amount of solar heating that the Earth's surface is absorbing. The amount of additional heat introduced into the Earth's system because of Arctic melt is equivalent to an increase in CO2 concentration from 400 to almost 457 parts per million. That's CO2 alone. That's not the CO2 equivalents that I alluded to earlier. Losing the reflective power of Arctic sea ice will lead to warming equivalent to 1 trillion tons of CO2. Advance this 2 degrees C threshold by 25 years. Now, I want to share this with you. We analyzed 40 climate models from modeling centers around the world. Said Eisenman, a professor of climate, atmospheric science, and physical oceanography at Scripps. Not a single one of the models simulated as much Arctic sea ice retreat per degree of global warming as has been observed during recent decades. Translation: our models underestimated what would happen. This motivated us to use an observationally focused approach to investigate the scenario in which all the remaining Arctic sea ice disappears considerably faster than the model simulate. Earlier study by the same team calculated the ice loss in the Arctic between 1979 and 2011, added 6.1 watts per square meter to the Arctic. Okay, that's to the Arctic alone. The value I cited earlier, the 0.21, that's globally, global average. This shows you how much faster the Arctic is warming. And when average globally is equivalent to as much as 25% of the effect of CO2 during the same time period. Additional research shows that the thicker multi-year ice, which survives year to year, is down to 1% of the existing ice. This is now going to lead us to the BOE events I described a moment ago. There's great uncertainty about the time when the Arctic could become seasonally ice-free, but the recent trend as early as the 2020s and others suggesting 2030 or substantially later, depending on factors including future warming and natural variability. Well, the models are now showing, as I said earlier, 2022 to 2024 for the first BOE event, and then by the time BOE plus 10, which basically puts us in 2032 to 2034, an Arctic ice-free ocean, one ice-free Arctic ocean. With all that heat and all the changes to the weather pattern and so on. Now, earlier I mentioned about the studies that said 7 to 9, maybe 10 degrees C by 2100 water variability, because water vapor is very difficult to model. Water vapor / clouds, because clouds are water vapor, very difficult to model. And depending on how the models, what they do with that parameter, can give us differing results. But it's still more than the 3 to 4 it's been, like in years past, shown to be what they think will happen. Now the consensus, 3 to 4 is an underestimation. We're looking 7 to 9, maybe more. Well, when you consider that the Paleocene, Eocene thermal maximum had temperatures about 16 C above pre-industrial revolution level, if you're getting up to 10, we're getting very close to PETM levels, which is the hottest the Earth has ever been. We're on the way to a hothouse Earth, but instead of taking millions of years to get there, it's only taken a couple of centuries. Very alarming. So when you look at what's going on here, we're warming the Arctic Ocean, warming the Arctic. The Arctic is now becoming something that is no longer recognizable as being Arctic. It really is not. I don't know what you would need to reclassify it, but it's certainly not typical Arctic conditions, and it's very alarming. With the warming, with the loss of the ice and the warming of the ocean, that's going to drastically change weather patterns, more intense storms, more intense heat waves. Warmer air can hold more moisture, so you're going to start sucking moisture out of the ground. The permafrost is going to keep thawing, and the ground is going to keep drying, leaving it vulnerable to fires, as we saw in Siberia this past year and the year before in Scandinavia and Alaska. We're seeing that food crop yields are going to decline, as well as nutritional value. Things are just rapidly happening, and it's not a pretty picture one bit. And now, it used to be said that the Arctic is warming twice as fast as the rest of the planet. It's now being shown to warming up 3 times as fast as the rest of the planet. And what happens in the Arctic certainly does not stay in the Arctic. So this is happening. And even if you were to get to zero carbon emission, that's a laudable goal. Is it realistic? I don't think so. Yes, say everyone went around driving electric vehicles. You still have to plug it in your house at night. And what powers your house? Power plants that burn coal, diesel, gas. The medical industry, big user of plastics. An IV bag, the tubing that goes to a little valve, eventually goes to a needle, which is metal, that goes into your arm or your hand, wherever. But all that's plastic. Plastic is an oil product, petroleum product. So, and even if we did get to zero emissions, we did an experiment earlier this year, early in 2020, with the lockdown due to the virus. Basically, planes were grounded. And we did measure a noticeable drop of CO2 addition to the atmosphere. It was a noticeable drop. Temperatures, although didn't increase as fast as it normally would, temperatures still increase, albeit at a lesser rate, but it still increased. And that's because of the thermal inertia in the system. We have set things in motion, and it's going to be very hard. We've opened up the bottle. The genie's been let out. It's going to be very hard to push that genie back into the bottle. So there you have it. Kind of a dark picture, but it is what it is. And my job is to present to you what it is. Thank you for your time. Hello, folks. This is Jim here with Science Talk, asking you to please subscribe to my channel and to inform others of my channel and of the work that I do. Please share to social media platforms that you use. Also, as a reminder, don't forget to click the bell so that you know when I load up more videos. Finally, I ask that you support the work that I do by becoming a patron at patreon.com. Details in the description box below. Thank you for your support.